Welcome back to Chem 101. In this first video on empirical formulas, we are going to do some calculations and actually calculate empirical formulas from information in grams about the constituent elements.
Alright, we're going to calculate empirical formula from grams. So we're going to have gram or mass information about our starting elements. Okay, so let's say that we have 2.4 grams of carbon, 3.2 grams of oxygen, 4 grams of hydrogen. So we know that our molecule is going to be C something. O wouldn't go next, hydrogen would go next. H something, O something. We don't know what those numbers are yet. And that's what we're calculating in the empirical formula. We're calculating those numbers. So we start with carbon, or with any one of them. We start with any one of them. And we want to figure out how many moles we have. So we would say, we'd look up the periodic table, we'd see the element, the molar mass for each one of these elements. For carbon, it's 12,011 grams, 1 mole of carbon. And we want to see how many moles that is. Oxygen, 15.999, 1 mole of oxygen. Hydrogen, 10079 grams is 1 mole of hydrogen. And so let's get actual numbers. And we get something like this. 0.1998 moles of carbon, 0.2000 moles of oxygen, and 0.3969 moles of oxygen. Alright, so we want to figure out which one of these is the smallest number, and we want to divide both of, or all of them by that number. So let's figure out which is the smallest. 0.199, 0.20, or 0.3. So this one's going to be our smallest one here, 0.199. So let's divide everything by that number. We're going to divide this by 0.1998, and that's going to be equal to 1. That'll be the only one that's equal to 1 exactly. One of them, though, no matter what problem you do, will always be equal to 1. This 0.1998, this is actually going to be very close to 1. 1.00. We got some ones here. And then the last one, 0.1998, is going to give us approximately 2. So this is our molar ratio. We want whole numbers here. We'll do an example of one that doesn't give us whole numbers. This one gives us whole numbers. So when we write our formula, now we can get rid of this X and this Y and this Z on our molecular formula. We can plug in for carbon, it's just going to be a 1. We can just leave that blank. For oxygen, it's also a 1. For hydrogen, it's a 2. So it would look like this. Carbon 1, hydrogen 2, oxygen 1. But we leave off those 1s. And so that's our empirical formula. Alright, let's do one more. Let's say that we have a compound that some scientist decomposes it, and we find out that it's made up of 3 components. It's made up of beryllium, it's made up of sulfur, and it's made up of oxygen. And they've broken into these pieces, and they actually have a mass for the beryllium. It's 2.128 grams. They know the sulfur. It's 7.557 grams. And the oxygen is 15.107 grams. Alright, so we need molar mass information for these guys. For beryllium, that is 9.012 grams per mole. For sulfur, that is 32.06 grams per mole. And for oxygen, that is 15.999 grams per mole. Alright, so we want to start with beryllium, or whichever one we want. 2.128 grams of beryllium. We want to know how many moles So 9.012 grams is 1 mole. We will do the same for sulfur. 7.557 grams of sulfur. The molar mass tells us that 32.6 grams is 1 mole. And oxygen, 15.107 grams. And it looks like we almost have a mole of that. 15.999 grams is 1 mole. So we'll almost have 1 mole of oxygen. Alright, and so these values come out to... Alright, we want to identify now which one of these is the smaller number. And by a hair, this one's smaller than this one. So we're going to divide everything by 2.2357. 2357. 0.2357. Okay, and we get, for sulfur 1, we're going to get about 1 for this guy, and we get 4 for oxygen. So that tells us that our formula is going to be Be1 S1O4. So it's our empirical formula. Now what if the situation had come up where actually one of our numbers didn't come out to be even or exactly 1? Let's say that these, we divided by 1, but this one came out to be 4.5. What would we do? And that didn't happen, but what if that happened? So let's say your numbers come out to look like this. We need to multiply all of them by something that's going to give whole numbers again. So the easiest way to do this, I actually have a table on the PowerPoint that you can look at. But we want to multiply these by something that's going to give back whole numbers. So if you see, if we multiply everything by 2, 2 times 4.5 is going to give us 9. And then we'll get whole numbers again. What if we had 1, 1, and 3.25? Well, we would want to multiply again by something that's going to give us whole numbers. If we multiply by 4, we'll actually get 13. So we get whole numbers again. So let me show you what that table would look like. Let me get rid of that. So if your number ends in something like 0.1, we're going to multiply it by 9 to get back to a whole number. If it ends in 0.2, we're going to multiply it by 5 to get back to a whole number. If it ends in 0.25, we would multiply by 4. If it ends in 0.33 or something close to that, we multiply by 3. If it ends in 0.5, we multiply by 2. Let's see. If it ends in 0.6, you could multiply by 5 to get back to a whole number. 0.7, you might have to multiply by 10. In the end, you might just need to round whatever number you have to the closest whole number or closest, fractional number, and then multiply by another number to get to whole numbers. But that's a rare case when that does happen. So you don't need to worry about it too much. Alright, in the next video, we're going to calculate molecular formula.